In this session, we're going to cover more the area of smart mobility in the air. So again, I want to thank you, our sponsors, NTT and Cisco. So just to give you a little bit of an introduction, my name is Barbara Pareglio. I work in a GSMA. I will be your host for this session. And we're going to have a lot of presentations and a panel discussion with a lot of distinguished speakers. So I hope you're going to enjoy the session that we have today. I'm not going to go through to introduce all the speakers that we have today. We will go through while they come on stage. But I don't want to waste too much time because I really wanted to listen to the presentation and the panelists. So with no further ado, I want to introduce our first speakers. So Kedar Garat from Qualcomm, please welcome on the stage. Over to you.
Hello, good afternoon, everyone. I'm Kedar Garat. I work as product and business lead for drones and unmanned aerial systems at Qualcomm Technologies. And I'm here to give you our view of how, of the market scenario and where we see unmanned aerial world heading to. So just a quick snapshot of where drone industry is today. We are seeing tremendous growth in both commercial and consumer or enterprise drones, as you would call it. And what's fueling especially the enterprise growth, the enterprise segment, is the huge increase of applications or end-to-end use cases that are enabled by powerful on-device compute and 5G connectivity. We'll be talking about some of these applications in my future slide, and that's something we would like to jump into. So Qualcomm has been no stranger to drone world. Our leadership in drones stems back to the first platform we launched in 2015 with Qualcomm Flight platform. This was our first reference platform to build your own drone. Drone industry, unlike mobile phone, is not some place where you could start with a chipset. And this is where we started releasing development platforms to accelerate the growth of this industry. This was a platform that powered the NASA Ingenuity helicopter. We are very proud of enabling the first powered autonomous flight on planet, beyond planet Earth, in fact, on any other planet for that matter. We followed it in 2018 with the Qualcomm Flight Pro platform, and more recently in 2020 and 2021, we launched Qualcomm Robotics 5G platform and Qualcomm Flight RB5 5G platform for the drone world. Both of these platforms were first in their respective industries to bring 5G, integrated 5G, to their respective industries. Now, speaking about applications, which is what I was talking about earlier, we'll go through some of these use cases and figure out what transformation 5G is bringing to this use case. Film and entertainment. Drones were already a go-to medium for aerial shots, for landscape photography, even before the advent of 5G. And with 4K, 8K being made possible on drone and massive resolution cameras being enabled on drones, we expect content creators to still blow our mind with insane next-gen photography and cinematography. What we are hoping to unlock, and we are seeing unlocked with 5G, is live streaming of events that wasn't possible until now with low latency, high-def video streaming. I'll skip delivery because we have someone here to talk about delivery use cases. Public safety is the next important use case. Again, drones are no stranger to first responder use cases. First responders are already using drones today in many shape and form. What we are seeing more and more is first responders are trying to use drones in a more structured manner. Think about getting a 911 call and the drone being autonomously able to take off, navigate to your destination, start streaming live video, and giving you a very crucial situational awareness of what the first responders are going to walk into. For police officers, this is a very powerful de-escalation tool. For other first responders, firefighters and everyone else, it helps them prepare and understand what they're going to walk into. And like I said, it's a very powerful de-escalation tool. It's a very powerful tool for them to manage their resources and figure out where their resources should be put on. Again, the use case for 5G here is, as you can imagine, you need to stream real-time, high-def, high-quality video. And with low latency, and the bandwidth that's possible with 5G, this is very close to reality. Precision agriculture, to do scouting for weeds, for insects, for diseases, precision agriculture drone is the right platform, right? You can cover large swaths of areas, and again, this is something that's been actively worked on in many use cases. And I won't go into every single use case for inspection, but underneath that umbrella, you're talking about construction management, you're talking about transmission lines, utility, distribution lines, essentially everything under, any expensive asset that you want to inspect, having a drone that can autonomously fly, navigate around the object that you want to inspect, and then have powerful on-device compute capability to provide actionable intelligence is what will unlock these use cases and what is unlocking these use cases. Now, I skipped delivery because we have Speedbird CEO here, Manuel from Brazil, who have been doing enabling these drone-based delivery use cases for the past 3 years in Brazil. And they are now announcing their entry into North American market. So I'll hand it over to him for the next 2 slides. Yeah.
Well, thank you very much. Good afternoon to everyone. Thank you, Kedar, for the kind introduction. I'm Manuel Coelho, the CEO of Speedbird Aero, a company that was born in the United States, left the US to get the type certification done in Brazil. Now we are certified in Brazil, Israel, and we just moved back to the US. The good news that we are here to present is that drone delivery is commercially viable. And that's what we can do. If you can prove it in Brazil with even the real, the currency differentiations that we have and the discrepancies, we can prove it here as well. So we started with a case on the top of a shopping mall with the biggest food delivery company in Brazil, saving 15 minutes of delivery time, which is actually crucial for the customer experience. Then we moved to swine semen delivery. We're talking about now in the rural area where we're doing artificial insemination, going from clean area to clean area without touching the soil, which is a huge source of contamination. Everyone here probably heard of mad cow disease and a foot and mouth disease. This is generated by contamination of the soil, right? And there's big companies using it. This is the first one that's connecting 2 cities in Brazil using drones. And very important because it's working with the biggest dental implant company in the world, Straumann Group. This one is the biggest brewery in the world, AB InBev, in Rio de Janeiro, where we're saving about 50 minutes of delivery time going straight to the beach from the distribution center in Rio. Another big, we have a beautiful video. We can actually make it available so you can see the first city to actually adopt this technology and have a pilot project for the capillarization of the city. Well, now cities are fighting to have this type of structure and capillarization. Salvador, which is the first capital of Brazil, very large city, has now 12 points serving 1.2 million people with a radius of 3 kilometers, less than 2 miles. That the last mile can be done with a scooter, electric motorcycle, therefore keeping the carbon footprint low. That's what we're aiming to do here with technology. And the last one is we fly daily, night flights, delivering over 100 meals a day with 2 drones now in parallel in the capital city of Aracaju in Brazil. And just yesterday, we finished our project with Eve in Chicago, Illinois Medical District, flying from an urban air mobility vehicle into a drone directly to a hospital. So that's what it is. And the most exciting part is what we're building now with Qualcomm and being able to take the next step, the next generation of our drones, making it lighter, energy efficient, and safety. It's safer now. We're working with the brains. What Qualcomm is actually empower Speedbird to do. So thank you again, and we're really looking forward to see this industry thrive. And thank you again, Kedar, for your kind introduction.
So the question is, what next, right? Where do we go from here? And what we are creating next is a very comprehensive platform for next generation of urban air mobility solutions, right? That encompasses everything from digital cockpit, autonomous navigation, telematics, and UAM to cloud solution. And just to double click on some of this, right, we'd be leveraging heavily what we have already done for the drone space. We'll be leveraging heavily what Qualcomm Automotive BU has done in the automotive industry with Snapdragon chassis, with cellular V2X, vehicle to everything standard, and see how that's applicable here, and really enable anyone and everyone, the tier 1 manufacturers to the end customers who want to build their next generation UAM solution. So we are very excited about this new and upcoming space, and we plan to play a huge, impactful role in this space.
Again, we had a great introduction, so we're going to have now the next presentations. So I want to welcome Francesca Gazzola from Honeywell.
Well, thank you, Kedar. You lined me up perfectly, ending on urban air mobility, because that's exactly what I'm here to talk to you about. And at Honeywell, we are taking a century of history and excellence in avionics and bringing that to the UAM market, looking to advance the advanced air mobility through urban air taxi and cargo delivery, all through electrically powered vertical takeoff and landing systems. And we have a vision for a 100-mile trip through air taxi in 45 minutes. And autonomous cargo and package delivery, same day, anywhere in the world. And we're doing this and working to enable the industry through a hyper-focus group that is working in the area of advanced air mobility, and by enabling all forms of electric propulsion. So what does Honeywell do in this space? So my colleagues like to joke, outside of the airframe, we really kind of can do everything. But in addition to what you see here in the air, we also have roles in the ground control station and other ground systems, as well as communication too. So when we talk about advanced air mobility, what are we talking about? I know we've talked a lot about drones, and then we talk about air taxis. The first thing that I want to lead this into is I encourage you not to look at urban air mobility, advanced air mobility as a trend. I encourage you to think about it as an evolution in transportation. People lose hundreds of hours of their year just to commuting in urban areas. There are billions of packages being delivered every year, and we're consuming more and more. We have to get more sustainable at moving people and moving things because we're becoming a much more mobile world. And advanced air mobility can take a variety of different forms. It can look like delivering passengers in urban areas, delivering cargo in rural or outskirts areas, and delivering packages and perhaps other forms as well. But it's all going to depend on a few common things: advances in autonomy, advances in electric propulsion, and advances in communication networks. A lot of my career in the space has been at looking at the operationalization of networks, and that has led to looking at the services that are above and beyond the network that need to come to life to support the operational approval of these missions. So, in Mobile World Congress in Barcelona earlier this year, I showed this diagram, and I talked to the ecosystem interactions from the perspective of a mobile network operator. And I called out a few things here. One of them being is that we can't look at network services in a silo. And the second being is that we have to, I apologize about that. Some of the things aren't showing up here. But the second thing being the importance of the contextual awareness of a mission when it comes to looking at services that are above and beyond the network for the purpose of operational approval. And from the aircraft service, from the aircraft perspective, all of these services are third-party services, including the mobile network. And so recently, the FAA has been acknowledging the importance of third-party services in enabling the safe, scalable, and efficient operation of uncrewed aircraft systems. And I want to encourage us to think about the fact that the importance of a third-party service is not that it's been designed only for the perspective of serving aircraft. So a mobile network doesn't have to be designed just to serve an aviation system. But what it does have to do is be designed to explain to that aviation system or make transparent and make technically clear how the system can be utilized. Because every system is going to be utilized differently based on the airframe, based on the mission, and based on the type of operation that these are performing. So clearly, technically articulating the operational boundaries of a network and the operational performance and the services that are dependent on that is very, very important from the perspective of the aircraft and the ground control station. And advanced air mobility is going to look like something different today or in the future. And today it looks a lot like traditional aviation. It looks a lot like taking a helicopter from JFK into the New York City Center in 15 minutes. Or it may look like a rideshare service through privately owned aircraft from Las Vegas to Portland. So advanced air mobility tomorrow in the emerging future looks like piloted electric aircraft during urban air mobility and passenger delivery in urban areas, and autonomous cargo in rural outskirts areas where the risk is lower. And of course, our future is one person controlling mini autonomous aircraft delivering people and goods all over the world. And the services that can support that, including the mobile network and services that utilize the mobile network, are going to look different at each one of these stages. Today, it looks like probably just giving access to a network and having proper policies to even access a network and be able to get onto it. Tomorrow, it might look like providing C2 communication services that are above and beyond the network that we've talked about and we may talk a little bit more about today, like coverage and population density for the purposes of planning a flight. And in the future, it gets really, really creative because we could start talking about things like dedicated spectrum or network slicing and advanced concepts in the way that networks can support detect and avoid or deconfliction. But I encourage you to think about there is stuff that can be done today to advance this, and mobile networks have a great role to play there. And not only is it going to look different through the evolution, but it's going to look different through the stage of flight. So at all stages of flight, the way that you utilize a network as a third-party service is going to look different. It's going to look different. So we always need to be thinking about the ground infrastructure of the vertiports for advanced air mobility or where places are going to be landing and taking off. And at the beginning of a flight, we might be thinking about how to obtain operational approval, assess various flight paths, and get that mission up in the air and a flight plan approved. And now while you're in the air, we have the command and control services because we're taking the pilot out of the loop, putting them on the loop, situational awareness, and services that may provide detect and avoid or deconfliction, such as V2X services. But we also have to think about the passenger, because the passenger is going to demand some kind of services, whether it's in-cabin connectivity or whether it's for the purpose of safety, the air traffic control or the ground control, sending a voice signal over to that customer. And if you want an interesting challenge to solve today, talk to some advanced air mobility companies and ask them how they are handling voice from the ground control station to air traffic control today. And that sounds like a simple problem from the perspective of mobile network operators, but it's not, and we need some help on that one. So at the end of the mission, we again have the importance of the infrastructure, but we also have the offloading of data for the purpose of maintenance and aircraft diagnostic. And we may use the network for the perspective of doing precision-based navigation and other types of data offloading. But the most important thing is that we're able to do secure network edge processing so that we can keep that operation moving quickly. And underpinning all of this is cybersecurity. From the very beginning to the very end, cybersecurity has to be thought about from day one, because you can't design a piece of the system and then come in later and bring cybersecurity into it. So we really have to be thinking as a group. And so in closing, this is mobility in a different dimension. And an aircraft is not going to take off in the same environment as it landed, or it's not going to land in the same environment as it took off in. So we need to think about mobility above and beyond just the network. Mobility from one network environment to another network environment. Mobility across different performance pieces inside of the network. Like, it looks a lot different to get services on a low bandwidth or a low frequency 5G than it does on millimeter wave 5G. But ultimately answering how do we look at mobility, because networks are not deterministic, is going to help our regulators too. And so there's some conversations that we should be having, and I think we're going to start some of those today. And that's around spectrum, around millimeter wave, around hopefully operators being able to publish flight data and how that can enable the urban air mobility and advanced air mobility markets. And if anything here is interesting, I'm throwing up some resources. I encourage you to snap a picture, get involved. We really, really, really need more industry input and engagement here. So yeah, with that, I think we're going to move into a panel and hopefully dive some more into some of these topics.
Why don't we go ahead and get started? The first thing I want to do is give folks here a chance to introduce themselves in just maybe 30 seconds about who they are, what company they work for, and what they do in that company. So, Francesca, we'll start with you again for an abbreviated introduction.
Yeah, so Francesca Gazzola, I am a director of product management for Honeywell, and I work in our defense space, creating software, and also work with our AM and UAS teams as well.
Thank you.
Stefano Faccin, Qualcomm. I'm Director of Standards, and I work on standard and regulations. I'm a long timer of 3GPP, but I moved into the aviation field in the last 4 to 5 years.
Thank you. Rob?
My name is Rob Roy. I am an Executive Vice President and GM of Innovation at TIOCO. We have been looking at drones, UAS, as a innovation area, and have come up with some ideas to bridge between the cellular network and the drones needs.
Adrian?
Adrian Buckley, I'm over at MITRE. I'm a principal over there. I support the MITRE Ingenuity Open Generation 5G Consortium. I know that's a bit of a mouthful. Primarily over there, I lead their standards activities and also oversee deployment of private 5G test beds. My career consists of working for operators on 3 different continents and smart UEs on 2 continents over the past 30 years. And I've been in 3GPP since its inception.
Okay, so thanks for everybody for your introduction. Again, I'm Peter Musgrove. I'm with AT&T in the Standards and Industry Alliances area. So let's get straight away and start off with the questions. I'd like to start off with Stefano first. The FCC has recently issued an NPRM, which those of you that follow this space would know about. They're looking to get spectrum in the 5030 to 5091 megahertz range. They want to use it for perhaps C2, detect and avoid, and even broadcast remote ID. So the question is, what's your opinion about this proposal, Stefano, and what do you think the position of the GSMA community should be?
It's a very important question, thank you. It's what Francesca mentioned before. We fully support this proposal, and we think that more companies in the aviation industry, especially UAV operators and UAV manufacturers, should look at it, because we think for this industry to really explode and develop to the right point, and to provide the correct amount of bandwidth and safety of communication for drones, we will need a dedicated spectrum. For sure, for the applications that require device-to-device communication, but also for the command and control, because we see challenges in using the normal spectrum allocated to carriers to do the command and control. It will not necessarily work in all the scenarios, in all the locations. And since there is bandwidth that is generously being made available, why not taking advantage of it now that it is available, instead of later on having to seek for it? So we think this is a very good proposal, and we strongly urge everybody to look into it and express an opinion. The FCC is asking for opinions, so please take a look at it and provide your opinion.
Yep.
Okay. Thank you, Stefano. I know, Francesca, you also have some ideas about spectrum use for UAS as perhaps a follow-up here.
Yeah, I too support it and encourage everybody to get involved. And one of the biggest challenges that we have for mobile networks today, they're so well built to serve drones, and there's so much great applicability there, and it's a great monetization opportunity for mobile network operators. We're spectrum limited. Very spectrum limited. Here in the US specifically, we're very spectrum limited, and I know there are some restrictions globally as well, but that is a challenge. And so having the ability to have the conversation about how we expand spectrum, however that is, very supportive, and I think it's really important. The second thing is that there's some real great benefits that would come along with having dedicated spectrum for drones. I mentioned the fact that mobile networks today are not deterministic, and that is a challenging thing from the perspective of a drone, because you have an aircraft flying, it banks left, it does a handover, and Tioco has software that can really break this down, but how is that managed from a network? Is a very challenging thing. How is it managed on a different aircraft? And when you need to go to the FAA and say, I need operational approval for this high risk or riskier mission, they need to know that you're going to perform in a particular way. And having dedicated spectrum is one way, not the only way, but it is one way to serve those more advanced use cases.
Thank you, Francesca. Next, Rob, I'd like to turn to you and move to the subject of private cellular networks. So when we talked about 4G, there was some talk of private networks, but it seems to have exploded in the 5G environment. So as applied to drones, where do you see the opportunities here?
Very interesting question, Peter. So there are some, obviously I think we all are familiar with many examples of what is being done in private 5G. There are things in the press. Verizon has been working with the ports in Eastern Seaboard in Virginia for deploying private 5G. Now there are a few interesting cases that came to our attention. So there are some mines in southern part of Africa, South Africa, Botswana, Namibia, where the mines are a little bit far away from the population base. There's no cellular coverage. They are spread out, so they would like to, case in point, in a particular part of the mine, they need a tool, a particular type of spanner, for example. They need to have the truck drive through these terrains up and down and so on and so forth. So they would like to deploy these kinds of needs using drones. Okay. Now, these drones need to be controlled, and they need to go beyond visual line of sight because of the terrain is such that you don't get a single point of control from which you can control the drone. So this is an example where a private 5G setup it's like an island. It's not connected to any other outside network. Maybe with Starlink or Project Kuiper or OneWeb, it may be connected someday, but as of now, it's not connected to the rest of the world. But it's a private 5G network, or LTE for that matter, which enables flying of drones beyond visual line of sight in an area which is sparsely populated or possibly unpopulated. Just an example of the cross between private 5G and the drone world that is coming together.
Okay, thanks, Rob. Adrian, as a follow-up to this on private networks, certainly there's a place for these kind of networks, but they have a lot of challenges. And I know from some of your previous employment experience you have, and even your current experience, you certainly have some things to say in this.
Yeah, I was going to say, I've been involved with deploying networks in the UK and both in the US in the mid to late 90s. And now over at MITRE Ingenuity, we're deploying these private 5G networks specifically to conduct experiments on, UAV experiments. But private networks are great. They offer a lot of benefits, like Rob has just said. But, when you go from maybe the traditional operator to operating a private network, it's kind of then gets into the operational aspects. You see, kind of like who is deploying and operating that network. I mean, if you go and have a look at, like AT&T or Verizon, they've got like hundreds of staff that are dedicated to particular roles in there. So we're taking Rob's example of the mining situation. You can imagine, well, you've got to make sure you have the coverage in the right places. Now you're going to have to do RF analysis, coverage maps and simulations and everything like this. So you're getting into the skill set of it. Who is doing this? Maybe you can subcontract out to the local operator in that region, or there's other people that do it, or you can actually do it in house. But those are just some of the initial challenges. And once you've got the spectrum and maybe you've analysed where to put the particular cell sites, then you've got all the other things that you've got challenges with. I mean, one of the things that we've found is that with a lot of the UEs, or actually the smartphones that we all have in our pockets today, they work with, like the Orange in Europe and the Deutsche Telecoms and AT&T and Docomo and people like this. But then when you start to maybe try and use them in a private network, depending on how you've configured the private network, you find out there's some little nuances in the software that completely stop you from using it. Mm-hmm. So there's a lot of these types of things you've got to go in and investigate. If you're going down the path of deploying a private network, you've got to make sure that you engineer it correctly, so that when you start to get the equipment that you can deploy it and then also operate it. And then finally, there's the day-to-day operational aspects. Some point in time something goes wrong and you need to know why it's gone wrong. And even when you're deploying it, you may have to go around and optimize it, because simulation tools are not always accurate. You may want a particular piece of coverage over in that part of the mine, and just because somebody's rolled in a big crane one day to excavate something, and now that coverage is gone, so you're going to have to reconsider the deployment thing. So there's a lot of operational aspects, but they're very interesting to work on, just personally.
Okay, thanks, Adrian. So I want to talk a little bit about how the mobile network operator world can sort of intersect effectively with the world of aviation. I mean, this is a big signature event that you're at now for the GSM Association. Hopefully, most of you know the GSM Association has a joint activity with GUTMA, the Global UTM Association. This is called the ACJA, the Aero Connectivity Joint Activity. That group has been talking a lot about standards, particular in the aviation field, standards like the RTCA and the EuroCADE group. This is a question for Stefano. So with these standards in the aviation field, they're looking at the architecture of UAV and AAM ecosystems currently. They're defining requirements and other building blocks for this ecosystem. What do you think the role should be for GSMA members in fulfilling support for this ecosystem?
Those of you that know me probably are tired of hearing me saying that we need more participation. So there is a big opportunity, because ACJA was created with the idea of putting together the normal cellular industry, the usual cellular industry, with the aviation industry. That in the past there have been efforts, as an example, in 3GPP to define solutions that are very good solutions on paper, but nothing was ever asked to the aviation people. Do you actually need this? Is this what you want? The aviation people have a lot of ideas, but they don't necessarily understand how cellular networks work. So even just translating what you need in terms that they can then be brought to the cellular world, it's a difficult step. ACJA has the ability to do this by having members from the operators, from the builder, from the vendors, from the devices, and from the aviation that can come in, can actually build this glue between the two industries. Because quite often, I can give an example. We were in some RTCA or OK calls. We noticed that we still have a lot, after years of talking to each other, a lot of loss in translation because of the different terminologies between the two industries. Because the same term, some people threw out some terms and there was a major reaction, because to the other industry it means something completely different. When you try to put those things together, define requirements and then bring them to standard and make them happen, it requires a lot of effort. And I think the GSMA community has a lot of people that can contribute to this. So this is really a call for action. Please, we are very happy to hear more voices, to have more people participate. Now, I understand that not everybody has the resources to be in weekly calls or doing things like that. But please let us know you're interested. We will find a way to rope you in, or at least to get your feedback. Because we don't necessarily need you to be in every single call. But if we know that you're interested, or you have a voice to express, we will contact you. We'll say, hey, we're about to issue this paper, or we are working on this. What is your feeling? What is your view? What do you need us to do? So I think there is a big role that needs to be played. But we need to get moving and get the companies involved.
May I add something there?
Oh, sure, go right ahead.
Yeah. I also think, and we were having an internal conversation about this earlier, the business case, the forecasting. Networks, when I sit down in a room with somebody and they're like, well, what can the network do this? Can the network do this? Or what can the network do? And I'm like, what are you going to pay for? Networks are incredibly powerful. A lot can be done. The work that's been done in 3GPP, the work that's been standardized, a network can do it. We'll just tell you that today. The question is, can it do it in a way that is scalable and economic enough for the industry to latch on to? So it's a two-way road. I will tell you today, the networks can do it. The way that we're going to get traction is for the aviation, and not just the aviation industry, but the software and the services that need to leverage the network, that are dependent on the network, need to come forward and be very prescriptive about, here is what I need, and here is how I need to interact with your network, and here is my current business case, my propensity to pay, because that is where the conversation starts. And that is what also fuels us to adopt these standards activities, because the work that's done on the standard side is done to advocate for the industry, but it only gets adopted if there's a business case there. And ultimately, if you want the networks to evolve in the way to support these services, you've got to come to the table and say, this is what I need done. And the answer can't be, I need everything. Or it can't be some, I need this much, without really, really putting a lot of thought into how you can optimize and smartly and efficiently use a network. But that's, it's a place that it's business.
Can I add one thing?
Yeah.
Yeah, I just wanted to add another thing. I think it's actually a concrete example. So let's consider drones that are using cellular connectivity and have a remote pilot sitting in an office somewhere in front of a computer. When we talk, as an example, with EORCAI and RTCA, one common question comes up. Yes, we trust the security of the cellular link. Yes, we trust the security up to the edge of the network. How about from the edge of the network to the computer that's controlling the drone?
Yep.
So they don't know what can be done there. Do we need VPN solutions, something like that? GSMA had the same problem when voice over IP came out. How do we put voice over IP, the two entities that are making the call, that could be from different operators, that could be from a computer to a mobile phone, interconnect, get the QoS that is required, the security, and the service level agreement? GSMA defined IPX and IPX Plus for that is in the interconnection network. So now we start talking in RTCA about what we call an aviation data network. But that is something that GSMA needs to define. What that would do, apart from opening up the business, will also make regulators happy and avoid a market where you're going to have 1,000 different VPN solutions for interconnecting ground control stations to UAVs. GSMA can play a big role in this, and I think it should play a role.
And it stitches the private to public network issue.
Yes.
That's moving from a private to a public network. For drones, they're mobile. They're going, it has to be considered. And these kind of things are what ensures that performance across those boundaries.
Hey, Rob, I saw you had your hand up on
Yeah,
this.
just a quick pointer. Typically, we all, including companies and people, we do certain things in a certain way because of motivators. Okay, either there are carrots and the sticks. Carrots, I'm going to make more money. If you come to me with a business proposal, here we go. You get the priority. I'm currently making X amount of dollars. You're going to let me make with the same resources or a small addition. You're going to make me 2X dollars. Well, show me where I sign, right? That's one. Second reason we do things because of regulatory reasons. highways of America are burning example, okay? I mean, there are ways we cut the corners, but generally speaking, there is a regulatory need. Same thing with cellular industry, there is a regulatory need. One of my friends who works at FAA, he gives a wonderful example. He believes that, number of aircrafts in the air is limited. So there is not a lot of need, there's no need to interact. There's a dedicated, people-driven, expensive systems for communicating and so on and so forth. Cannot be done for drones because of the distances are short and the overall, the cost per flight is limited. So because of, you can't do that. So when the demand becomes, it's like, how did the traffic lights get invented? In the beginning, there were only a few cars, they came, they stopped, they were not in a huge hurry. Slowly, the goodwill gave away. Whoever could go fast, they started. Then they brought these policemen who used to do stop, and then let people go. Eventually, that led to a traffic light, and now, we don't even think about it. Similar things is going to happen. He expects that there'll be pressure, there'll be areas where there'll be success. Some people will cut a little corner here, instead of flying 1 kg, they'll fly 1.25 kg, and then people will say, oh, it flew 300 sorties, 300,000 sorties, no accidents or minimal number of accidents. That's when the requirement of the cellular, which provides the connectivity for C2, will happen. That's sort of a view that is emerging within FAA, just to add that.
I've got a question for you, Rob, on that. Do you think that regulation should come first, or do you think maybe standards should come first? This is something I've seen quite a few times, kind of like in standards forum. Sometimes the standards won't develop until the regulations have been put down, or sometimes the standards want to, get ahead of the regulations, so the regulations adopt.
Good point. My view, the reason we are all able to communicate because we are speaking a common language. If you spoke Swahili and I spoke, Ubuntu, you would not be able to communicate. Yeah. So standards enable us to communicate with each other, where we are coming from different parts of the world. The regulations are needed for safety purposes and ensuring, like, I paid for this bandwidth. I don't want you to come in and start, throwing monkey wrenches on it. The regulations enable to divide clear fences where things operate, a protocol, whereas the standards are able so that people from different parts. So in some sense, they are connected together, but I personally think they need to talk to each other. Regulations should be connected to standards and vice versa.
Okay.
And Adrian, a question for you about how we can help accelerate this whole ecosystem.
Yeah, that's a good question. There's many different ways that you can accelerate this whole ecosystem. My favourite one is kind of like putting those standards in place, just because of my background. And I've seen many kind of like technologies get accelerated with the standards. But I think standards bring the interoperability and the predictability things, and also the economies of scale. But sometimes the standards can also be a slow process as well. And then if you don't get the right people involved, like Stefano said, we need aviation experts and we need cellular experts, and you need the cellular experts in the aviation community as well as the aviation people in the cellular industry. Otherwise, you get the standards diverging off somewhere, and then the standards just seem to morph into particular monsters. And then it comes to, the industry then recognises they need something, but they don't know where to start within the standard, which bit do you implement and which bit you don't implement, type of thing. And this is again where, the GSMA, came in with the NG128 to help, kind of like profile some of the work that are done in 3GPP. And then it's always another story that I like to bring up is, it's not the first profiling activity. Another one is IMS, which started back in the late 90s and never saw any real deployment until, the late 2000s. And, I think Verizon were the first people that, publicly released something in 2011 or something. And when I talk about IMS, these days, if you have a look at your smartphone on the top, you might see VoLTE, V-O-L-T-E, voice over LTE, and what provides that is the IMS background. But IMS, by then, it started in the late 90s, and Peter and Stefano were involved in it back then, so I'm going to drop them in it. But it kind of went into 3GPP, then it morphed into a monster, it did, and then there was a need to kind of like get hold of it and then kind of profile it and bring it down. But it comes back to the standards can be good, but sometimes standards can take go off on their own road somewhere, and you need to bring them back, type of thing.
Well, speaking of standards and specifically on 5G, millimeter wave has been very important, and I want to go to Francesca and ask about opportunities that she may see for millimeter wave in the air as relating to these drones.
I love this topic. I think millimeter wave is fantastic for drones. Not small form factor drones, very power limited. That's going to be a challenge. So I think millimeter wave for advanced air mobility specifically in two very specific use cases. Number one, in urban air mobility, so in very dense areas where you might have GPS canyons and or shadows, and in areas where you have a lot of noise and you need to reduce your interference. So I've actually personally led a lot of research on deploying millimeter wave in the air and looking at this, and the performance is fantastic. You want to talk about low latency, high bandwidth, there is a lot of promise. And here's the beautiful thing, for mobile network operators, that's a way of monetizing spectrum and above and beyond in a place where there's a whole bunch of spectrum. And it's open for aircraft, so there's just so much to be done, and it's better in the air. You don't have trees and all this other stuff. You have this great propagation. So I think millimeter wave for urban supportive drone, larger airframes that have the capacity to for the power is really, really important. We need some advances in the hardware availability and the antenna designs. So I'm looking to Qualcomm to help us out there, and other companies as well, if you guys have something new. And also the second place that I see mobile millimeter wave as being really promising is in corridors, because I do think that corridors are going to be one of the starting foundational ways that we're going to start to actually crack this, building a road and infrastructure in the sky. And I know that the MITRE team has been working on some of that, but I think the idea, and I don't know if people are doing this yet, but private millimeter wave networks, deploy that idea for a corridor. I think we're on to something really special.
Okay. Stefano, there's some work, or this question is related to some of the standards technology work that you've been doing on detect and avoid for cellular and mobile operators. So how can this technology help avoid conflict detection and avoidance between aircraft for both uncrewed and crewed scenarios?
The detect and avoid and all the services related to it, I think is very important, of course, for traditional drone and for advanced air mobility. There is a lot of work going on in regulatory for requirements and in standards to try to find solution. And I would say that the traditional mechanism of the manned aviation are not necessarily suitable in all scenarios, especially in a super crowded environment with small drones like urban areas where you have a lot of drone delivery. I don't think we can apply the same technology. And I think in the end we will see that we will need a combination of solution, both device-to-device communication, because that address certain problems, especially imminent collision and last minute. But we think the mobile network can actually play a big role in supporting the overall detect and avoid. By leveraging edge computing, by leveraging continuous connectivity, we think that there is a lot that can be done to provide safety of flight for these devices. And standards are starting to look at it. We're starting to look at it through GVP, but there is also a lot of interest in other groups. ASTM is very active on it. So I think there is a lot of work to be done. It's another place where I'm literally hearing very few voices active, and I think we need to hear more perspectives. Because let's put it this way, Qualcomm is spearheading a lot of these. We might have great ideas, but we would like to hear more voices to make sure that we can really cater for all the scenarios.
Seems there's a lot of overlap with the CV to X
there
scenarios.
Is a lot of overlap. So we've done this exercise of looking what was done for the automotive industry with Cellular V2X. And you know what? A lot of the scenarios are in 2 dimensions, and now we're talking about 3 dimensions, but pretty much apply in the same way. Yes, the mobility patterns are different, but a lot of the problematics that we're trying to solve with V2X apply exactly in the same way to with flying vehicles. So we think a lot of the technology that was developed for automotive can be reused. Properly adapted, of course, but we can definitely be reused. And it's something, for example, we're doing now, as we speak, exactly in these days, in InterGVP, to make it available for flying vehicles.
Can I make a comment on that?
Sure, go ahead.
So often I hear the word and the phrase detect and avoid used when talking about CVDEX or V2V, or how can networks partake in detect and avoid. But I also encourage us to talk about how can networks support deconfliction. Because the two sometimes get confused to be the same thing, but they're very different things. And networks can be used to support deconfliction today. In traditional aviation today. And that could be a stepping stone in a way that mobile networks can be utilized, whether it's private, whether it's public, but mobile networks can be utilized today for deconfliction, and that just advances all of air traffic in general and starts to pave the way on that digital transformation to get to where we need to be for autonomous aircraft, which then can start more really complexly leveraging topics like detect and avoid through vehicle to vehicle or through other really advanced network operations. But there's a lot that can be done today if we start by using the terms deconfliction and then progress to detect and avoid.
There was talking about deconfliction, there was an interesting proposal I had seen that the idea was, imagine a few years from now, drone corridors, drones are flying, and one of the drones, the main power supply dies, okay, which can happen, not a matter of if, it's a matter of when. For whatever reason, malfunction, failure, whatever, bird hit, whatever the reason may be. One of the things happens is that the locational information is lost. So there was a proposal to, on the connectivity chip, put in a little battery which will be on its own, and it will at least continue through the network. There is no GPS information coming back to the drone hub, but the network knows where that device is, and if it's falling, and assuming it has some mechanism of breaking the fall through parachute or whatever the case may be, or just gliding, depending on the extent of damage, that can be an extremely valuable asset for people in our FAA world who worry about where this object is going to fall, on whose head is going to fall. So at least they know, at least for a certain amount of height, at some point we're going to lose. But assuming the other mechanisms are working reasonably well, because some of it is mechanical, not electrically powered, that can be applied. So the network can be used for deconfliction, and those unforeseen circumstances where you need to know where the location is so that other guys can prepare, or you can inform, you can send a NOTAM, or whatever the case may be, that there is a event that took place. So just wanted to let you know that if network is utilized properly, can be a huge asset to the whole industry, especially when all these guys, different companies, our friends, Drone Up, Drone Hub, Drone Down, anybody is coming and flying, they don't know what the other guy is doing, but they know that there is a problem and they are all informed. So that's a thought that I wanted to put.
Can I add one thing?
Sure.
By the way, I will now start calling it network-assisted deconfliction, because it makes a lot of sense.
Yeah.
I think it makes a lot of sense. I give an example. I don't know if you follow what happened in Spain 3 or 4 weeks ago with the TACA system, where a flight controller made a minor mistake and moved the location of a plane, which triggered the deconfliction between 2 planes, and while taking the deconfliction, triggered the deconfliction with other 3 planes. Now, this was in a 200 miles area with 4 vehicles. Now, put big city, 1,000 drone deliveries in a 2 miles radius. If one confliction is done autonomously by the drones, how many other conflicts are you going to create?
Sure.
Is the algorithm going to work? I don't think so. deconflicting this from the network before it even happens makes a lot of sense.
Yeah.
Then you still need, for other scenario, but because a drone may suffer an issue and lower in altitude for some reason, so you need more detect and avoid. But the deconfliction is definitely necessary.
Yeah. Adrian, beyond visual line of sight, I know MITRE OpenGen has been doing quite a bit on that with your facilities.
Yeah.
You want to talk to that?
Yeah, I mean, I don't know if people know about MITRE's. Like I say, it's MITRE Ingenuity, which is, I'm going to call it a subsidiary of MITRE. I'll probably get told off for calling it that. But within MITRE Ingenuity, we have this project called the Open Generation Consortium. And basically, one of the missions there is to accelerate ecosystems using 5G, and we've chosen the drone ecosystem. And as I said there, we basically do this by performing experiments on real-life use cases. So, you heard our colleagues earlier put up that nice slide with all of those particular use cases, and I know them all too well. I mean, we're looking at things like, hazmat incidents, linear inspection, package delivery, kind of like taking those real life use cases, creating a set of experiments around them, and then seeing how we can use the 5G ecosystem to basically accelerate the uptake of that. And one of the things is BV loss, which is a concern to the FAA. So it's kind of like, really, how can we address that? How can we convince the regulators and things that the 5G ecosystem is safe? But also, you have to remember, it's more about just being beyond visual line of sight. You also have to take care of, the other things that we've spoken about, like the detect and avoid and other things like that. It's a complete package of things that you have to bring to the table so that you can then operate on this BV loss. And so it's kind of like things that, we're looking at. And just to pick up on something else I did, because we moved on, but Francesco was talking about millimeter wave, and it's kind of like this is one of the things that we're doing. We're investigating deploying a millimeter wave network at one of our test sites. And I wouldn't be kind of like so optimistic as Francesca. I mean, even if you've got nothing in the way, and this is where it comes down to, using your computer models versus the real life. And we haven't got to the real life yet, but I mean, the computer models don't show that you get great super coverage, with the millimeter wave with nothing in the way. Mm-hmm. So I mean, there's benefits of actually, doing, experiments in kind of like a controlled environment. Using commercial systems. So we basically can take commercial systems, from the large people that everybody know, and we're using commercial spectrum as well, and we use commercial modems. So everything that we've got there is commercial, and we're seeing actually what you can buy today. What actually can you do with it today? And does it meet those particular objectives?
Mm-hmm. Well, and I do want to make a comment on that, because this is like where I encourage participation. Yeah. Because I never did it in a lab. We went straight to the commercial network in the real world, downtown Chicago, a couple other cities where it was deployed, and we were blown away. We're like, wow, you know what? This was so much better than we originally anticipated. So that just goes to show how much we still don't know about these systems and about how they can behave. So there's a lot to learn and to figure out and to see what can be done.
Great. Well, I appreciate all the answers you provided today. We're just a couple minutes over our time. I appreciate the audience sticking around for this. I'd like to hand it over to Barbara for a wrap-up.
I'm going to be very quick. So first of all, welcome, and if you're going to give an applause to our speakers. So again, it's been a pleasure. As been mentioned a few times, we have a lot of activity in GSMA, looking at the drones. If you are interested, please come to us or come to me. I will make sure that the list will listen to you. And if you're going to get involved, get involved.